Hi class. Another example about hypothesis testing, but this time we'll do two population proportions and we'll also do the confidence interval. Suppose we wanted to see if a higher percent of women voted than men. Say we sampled 80 men and found 45 voted, and we sampled 120 women and 70 voted. Can we infer that a higher percent of women voted than men? So step one, develop the hypotheses. So we're going to have the proportion of men is lower than the proportion of women. Now I just put men and women in this order because that's how it's stated in the problem. And the null hypothesis is the opposite of that, has to contain the equals. So I just emphasize the equals. Proportion of men is equal to the proportion of women. That's what we're going to see. That's what we're going to assume. And we'll see if we can infer this. Step two is assigning alpha, how willing we are to make a type 1 error, which is rejecting a true null hypothesis. We're going to assume that we may reject it, and we'll see, and that's our willingness to make that error. Now step three, does the sample results possibly allow us to infer HA? Is the proportion of women greater than the proportion of men? Well, the proportion of men is 45 over 80, which is 56%. Proportion of women is 70 over 120, which is 58%. So it is possible to infer that the higher percent of women voted than men. These are pretty close, so most likely we won't be able to infer it, but there we are, we could possibly infer it. Step four, what is our predictable distribution? Well, proportions are binomial, but that can be approximated by the normal distribution, so we'll use the z distribution. Okay, step 5 and 6, let's calculate the p-value. So let's bring in our calculator. All right, we'll turn it on, and we'll go into stats, tests, and we'll do a 2 proportion z test. So we'll go down to 6 on this calculator, enter. All right, so plug in the numbers. So x1 was men, so 45 men out of 80. Women was 70 out of 120. And we want the less than this time, so we'll hit enter there, and then calculate, and we'll hit enter. Okay, so our z-stat turns out to be really quite small. Basically minus 0.29, or minus 0.3. So we'll put that here. And our p-value turned out as 0.385. So under the assumption of the null hypothesis, which is that the proportions are equal, it's fairly likely to get this sample result. 56 and 58%. That's pretty close, and one would be greater than the other. So with this p-value, we don't have enough evidence to reject HO, so we won't. So since the p-value is greater than alpha, we do not reject HO. There is not sufficient statistical evidence to infer that a higher percent of women voted than men. There we go. Now let's do the confidence interval for a confidence interval for 2 proportions. So we go back to our calculator. Hit clear, we go into stats, and we go into tests, same thing. But now we're going to do not a test, but a 2 sample, a 2 proportion z interval, okay? And all our stuff is left over. 95% is what we want. So we'll go down to just say calculate, and here's our interval. All right. So let's see. So that's basically a negative 0.16 to a positive 0.12, or a negative 16% to a positive 12%. So we'll write that in. Okay. So our interval is from a negative 0.16, I think that's what it was. Let's check back, 0.16, yep. And to a positive 0.12, let's check that again. And we'll go into a calculator, and it was basically 0.12, okay. And or we can write it as percentages, a negative 16% to a 12%. Okay. All right, so that's the difference. It's a difference of 2 proportions. It's p, that's basically p of men minus p, I'll write it this way, p of men minus the p of women. All right, so for that, that's the proportion for that. And it contains 0. Okay, it contains 0. So 0 could be it, meaning that they could be equal. So sometimes P minus P of men minus P of women would be negative. That would be proportion of women is higher. But we're 95% confident that the true difference of the two is somewhere between minus 16% and positive 12%, which could be zero, which could mean that they're equal. Okay, hope that's helpful.